All right, today we're going to be talking about Chapter 7, Lesson 5. This is all about factoring linear expressions. And when we are looking at factoring linear expressions, the biggest thing that we should be looking at is what is the GCF, or the greatest common factor, of both monomials. Now, monomials are expressions that don't have like a plus or a minus sign between them. So 25, that's an expression. It doesn't have a plus or a minus sign, so it is a monomial. Same with x, same with 40x. These three expressions are not monomials because there is a plus sign or a minus sign between two terms. So these are actually not called monomials. Now, when we are looking for the GCF, or the greatest common factor, biggest thing we should be looking for is prime factorization. Prime factorization. And the reason why we do that is because when we find pairs of prime factors, whatever is remaining, and this will be important for factoring, so whatever we find as pairs is on the outside, and whatever we find as not pairs goes on the inside. So let's look at 48 first of all, and we can look at 28 after that. So 48, I can do 2 times 24. 2 is already prime, so I'm going to leave it alone. Here, I can do 3 times 8. 3 is prime, so I'm going to leave that alone. For 8, I can do 2 times 4. 2 is prime, and then I can do 2 times 2, and both of these are prime. So the prime factorization of 48 would be 2 times 2 times 2 times 2 times 2 times 3, and then we have a variable left over, so it should be x. Sorry, get rid of one of those 2's. For 28, same exact thing. I can do 2 times 14. 2 is prime. Leave it alone. To get 14, I can do 2 times 7. Both 2 and 7 are prime, so now I'm done. So the prime factorization of 28x would be 2 times 2 times 7 times x. I'm now going to look for pairs. So here's a pair, here's a pair, and here's a pair. So the GCF would simply be, here's a pair of 2, so it's 2. Here's a pair of 2, so that's 2. So 2 times 2 is 4. And a pair of x's, so it'll be 4 times x, which is simply 4x. Now, the cool thing is when we start looking for GCF when it comes to factoring, this number here would go on the outside of parentheses, and then whatever is left would go on the inside. And I'll show you how to do that in a little bit here. So example 2, finding the GCF of 14ab and 28ab. So same as above. I'm going to find the prime factorization of 14, prime factorization of 28. I have 2 times 7. That's the prime factorization of 14, and then I have an a and a b. With 28, I can do 2 times 14. 2 is prime. 14 would be 2 times 7. 2 and 7 are both prime. So the prime factorization of 28ab would be 2 times 2 times 7 times a times b. Look for pairs. Pair of 2's. Here's a pair of 7's, pairs of a's, and pair of b's. So 2 times 7 times a times b is going to be 14ab. And that's okay because sometimes one of the terms that we're looking for to find the GCF is the GCF. So let's utilize this information here to help us factor some expressions. So I want to factor 12x plus 48. So what I'm going to do is I'm going to look at 12x and 48, find the prime factorization of each. So 12 would be 2 times 6, and 6 is 2 times 3. So 12x would be 2 times 2 times 3 times x. 48 we've already done, but let's do it again anyway. So I can do 2 times 24. 24 would be 3 times 8. 8 would be 2 times 4, and 4 would be 2 times 2. So with 48, it's 2 times 2 times 2 times 2 times 3. Look for pairs. Here's a pair. Here's a pair. Here's a pair. So 2 times 2 is 4 times 3 is 12. That number goes right here on the outside of the parentheses. First number goes here, whatever is left. Second number, whatever is left, goes here. So 2 times 2 is 4. And then because there was a plus sign in between, I bring a plus sign down. If for some reason we would have had nothing left over in one of the areas, for example, if this would have been an x in both places, that would mean that this is also a pair, so there'd be nothing left up here. If that's the case, you must put a 1 in that location. So, for example, if I had, let's say, 6x plus 6, prime factorization of 6x would be 2 times 3 times x, and 6 would be 2 times 3. Here's a pair of 2's and a pair of 3's, so I'd be left with 6 on the outside, x plus, and then there's nothing left here. I would have to put a 1 because that's the same as times 1 at the end. So I need to make sure that that is something that is done. Example 4, let's factor 3x and 11. Now, the interesting thing is both 3x and 11 are already prime numbers. So 3 times x is 3x, and 11 is just 11. So in this case, the GCF, the greatest common factor, is there isn't one. Or the number would be 1. Which means that when I'm factoring a problem where there is not a greatest common factor, or the greatest common factor has to be 1, there is not another factor that is common between them, that means that this cannot be factored. And that's okay. Sometimes expressions can't be factored. And if that's the case, all you'd have to do is write down cannot be factored. All right, so this is the end of Lesson 5. If you have any questions, please let me know.